So this is the moving man simulation that is found in your velocity graphs direction Classkick page. So in this demo, we are going to watch the man start at a position of -10. So we're going to go ahead and put -10 meters since that's his starting position, or we can also move the slider all the way down. And then we are going to set his velocity at +8 meters per second. And so when we hit that, the slider is going to move to 8 meters per second. And now we see the man here is ready to get moving all the way to this house or brick. So we're going to press play and just watch what happens. And so we see that he moves, and then when we pause it, he stopped. All right, so now if we go to the charts, we're going to do the same thing. We're going to put his position at -10 meters, and his velocity will be at +8 meters per second. And so we'll see that the arrow moved, and the arrow here on the position time graph is at -10, and because that's where the man is located, and he's going to start moving at 8 meters per second. And so we'll watch it happen, and then we're going to stop it maybe about now. All right. And so we see that the line here is at 10 meters, or he's started at -10 meters, and then he kept going all the way to 10 meters. And then when he stopped moving, he just stayed at 10 meters while the timer went on. Here, the velocity of the man was at +8 meters per second, and he stayed at a velocity of 8 meters per second up until this point where he just stopped moving, right? And so you'll notice that there's a line here because that's exactly at the precise time that the man stopped moving, and we see that the man's motion will be at 0 meters per second when he stopped. Now, if we go back, so we'll reset everything. So this is for the second part. The second part of your velocity graphs direction. This time, the man starts at +10 meters and will move at a velocity of -8 meters per second. So we will press play, and we will see the man moving. And so then when he stops moving, we see that once again, the line flattens out for a position right here, flattens out, and here the man's velocity becomes 0 meters per second because he stopped moving. Questions that's found at the bottom of velocity graphs direction. We'll go ahead and summarize what you found out about velocity versus time graphs. The shape that is the velocity time graph when the object was moving at a constant velocity, we ended up seeing that it was at a flat line on the VT graph. For VT is going to mean velocity time. All right, and let me just make this a different color so that you can see it easier. All right. And so it's also flat line on the 0 meters per second, so flat line on the time axis when the man was still, or when the man was at 0 meters per second. So when he wasn't moving, there was a flat line right on the time axis. Now on the velocity graph, we saw that the object speed is when we look at the y-axis. So when we look at the y-axis, we can see where how fast it is because the velocity is on the y-axis. So if we just look across on the y-axis, the value there tells us what the speed is. Then on the velocity graph, we see how the direction of the object is in whether or not it's above or below the x-axis. So above the x-axis, so remember that the x-axis is time, means it's moving at a positive direction. And below the x-axis, which is also time, is moving in the negative direction. And so if we look at the Cartesian plane, so we have quadrant 1, 2, 3, and 4, we would see that above the x-axis in the positive direction, it's in quadrant 1, and below the x-axis in the negative direction is in quadrant 4. And that is it. So if you have any questions, make sure to email your teacher and they will get back to you.